You clicked because the title sounds impossible, and you were right to. Scientists didn't just discover unusual galaxies. They found fully formed cosmic giants that, according to everything we thought we knew about physics, flat out should not exist. And the world's most expensive telescope is the only reason we're finding out now. In the next few minutes, you're going to understand exactly why these galaxies are breaking cosmology, what the James Webb Space Telescope actually found, and why this changes the story of how everything in the universe, including us, came to be. We're going to walk through the discoveries one by one, starting with the find that sent shockwaves through the scientific community in 2023 all the way to a galaxy spotted just 280 million years after the Big Bang. By the end, you'll know why researchers are having to rewrite the textbooks and what they still can't explain. If the foundations of cosmology are wrong, everything we think we know about the origin of the universe and our place in it could be off. This isn't just an abstract science problem. It's the origin story of existence itself. The James Webb Space Telescope completely shattered what we thought we knew about the early universe by finding galaxies that basically shouldn't exist. These cosmic giants formed way too early, grew ridiculously massive, and organized themselves impossibly fast according to everything scientists believed about galaxy formation. When JWST first pointed those golden mirrors toward the deepest corners of space, astronomers expected to find small, messy, primitive galaxies stumbling around in their cosmic childhood. Instead, they discovered something that made them question the very basics of cosmology. Erica Nelson, an astrophysics professor at the University of Colorado Boulder, put it perfectly when she said, "It's bananas. You just don't expect the early universe to be able to organize itself that quickly. These galaxies should not have had time to form." Picture the universe's entire 13.8 billion year history as a single calendar year. These galaxies appeared by mid-January, and they were already the size of our modern Milky Way. This was the moment scientists went from intrigued to genuinely alarmed. 6 galaxies, all appearing where there should have been almost nothing. The most jaw-dropping discovery hit in February 2023 when an international team spotted 6 massive galaxies existing just 500 to 700 million years after the Big Bang. Here's how crazy that timeline is. If you squeeze the universe's entire history into a single year, these galaxies would have formed by mid-January. They're as massive as our modern Milky Way, packed with billions of stars when conventional wisdom said they should barely have a few million. Joel Leja, an assistant professor at Penn State, captured the shock perfectly. "We looked into the very early universe for the first time and had no idea what we were going to find. It turns out we found something so unexpected it actually creates problems for science. It calls the whole picture of early galaxy formation into question." The numbers are absolutely staggering. In those ancient galaxies Webb was designed to spot, astronomers expected objects no more massive than maybe a billion suns. Instead, those reddish dots in Webb's deep images revealed themselves to be 50 times more massive than that. These cosmic monsters would have needed to crank out hundreds of new stars every single year for the entire history of the universe up to that point. Compare that to our Milky Way, which forms just 1 or 2 new stars annually. Our Milky Way makes 1 to 2 stars per year. These ancient galaxies were making hundreds every single year for hundreds of millions of years. This is where the story gets personal. One team spent 7 years hunting a single galaxy, and what they finally confirmed rewrote the timeline of cosmic aging. Galaxy ZF-UDS-7329, discovered after a 7-year chase led by Carl Glazebrook from Swinburne University, represents perhaps the most mind-blowing find yet. We're seeing this galaxy as it existed 11.5 billion years ago, just 2 billion years after the Big Bang. Even at this baby cosmic age, it already contained stars that were 1.5 billion years old and boasted 4 times as many stars by mass as today's Milky Way. Glazebrook explained the incredible journey. "We've been chasing this particular galaxy for 7 years and spent hours observing it with the 2 largest telescopes on Earth to figure out how old it was. But it was too red and too faint, and we couldn't measure it. In the end, we had to go off Earth and use the JWST to confirm its nature." What makes ZF-UDS-7329 even more mysterious is that it appears to be what astronomers call a quiescent galaxy, meaning it had already stopped making new stars. This galaxy somehow assembled billions of stars, lived through its entire active phase, and settled into cosmic retirement all within the first 2 billion years of the universe's existence. It's like finding a fully grown oak tree in what should be a field of tiny seedlings. This galaxy was born, lived a full life, and retired, all before the universe was even 15% of its current age. Our own Milky Way is a disk galaxy. Finding thousands of them in the early universe means the conditions that created us existed far earlier than we thought. The surprises continued with the discovery of over 1,000 Milky Way-like disk galaxies hiding in the early universe, 10 times more common than astronomers previously thought. Out of nearly 4,000 galaxies spotted by JWST, over 1,600 were organized disk galaxies like our own, existing when the universe was just a few billion years old. In November 2025, researchers announced the discovery of Alaknanda, named after a Himalayan river. This galaxy pushes boundaries even further. It's a massive, grand design spiral galaxy with sweeping arms and a bright central region, existing just 1.5 billion years after the Big Bang. The youthful Alaknanda already spans 30,000 light-years across and forms stars at a rate 20 times faster than our Milky Way. Discoverer Rashi Jain explained the significance. Alaknanda has the structural maturity we associate with galaxies that are billions of years older. Finding such a well-organized spiral disk at this epoch tells us that the physical processes driving galaxy formation can operate far more efficiently than current models predict. Think of it like finding a fully furnished skyscraper in what archaeologists said was a field of mud huts. The construction speed alone defies everything we knew. Every new distance record Webb sets means we're looking further back in time, and each new record is revealing a universe that was more active, earlier than we ever imagined. Even more recently, JWST broke its own distance record by confirming MOM-ZE14, visible just 280 million years after the Big Bang. While smaller than the other galactic giants, this galaxy belongs to a growing group of surprisingly bright early galaxies, 100 times more numerous than theoretical studies predicted before Webb's launch. These discoveries created what some researchers call a growing chasm between theory and observation. The standard model of galaxy formation suggests early galaxies should have converted at most 10% of their available gas into stars. But these cosmic overachievers appear to have converted nearly 100% of their gas into stars, right at the theoretical edge of what's possible. Mike Boylan-Colchin from the University of Texas explained the implications. For galaxies to form so fast at such a size, they would need to be converting nearly 100% of their available gas into stars. While 100% conversion is technically possible, it would require something to be very different from what we expect. 100% efficiency is theoretically allowed, but it's like a factory running at maximum capacity from day one with zero ramp-up time. Something had to be very different about the early universe. Before you panic or get excited, it's worth understanding what breaking cosmology actually means and what scientists currently believe. Some scientists initially worried these findings might break cosmology entirely, requiring a complete rewrite of our understanding of the universe. However, newer analyses suggest the situation might be less catastrophic. Some of those impossibly massive early galaxies may appear bigger than they really are, due to supermassive black holes making them artificially bright. Researcher Katherine Chwarowski offered a more measured perspective. We are still seeing more galaxies than predicted, although none of them are so massive that they break the universe. The consensus seems to be shifting toward the idea that our cosmological model remains basically sound, but needs significant fine-tuning. The Webb telescope's $10 billion investment, a massive jump from its originally proposed $500 million budget, appears to be paying unprecedented dividends in cosmic knowledge. With its 6.5-meter gold-coated mirror providing over 6 times the collecting area of Hubble, Webb can peer deeper into space and time than ever before. We're not tearing up the rulebook. We're discovering it was written in pencil, not pen, and Webb is handing us an eraser. These discoveries are forcing astronomers to reconsider fundamental assumptions about cosmic evolution. The early universe wasn't the chaotic, primitive place we imagined, but rather a cosmic construction site capable of assembling massive, organized structures with remarkable efficiency. Rohan Naidu from MIT's Kavli Institute summed it up. With Webb, we are able to see farther than humans ever have before, and it looks nothing like what we predicted, which is both challenging and exciting. As Webb continues its mission, astronomers eagerly await more surprises from the cosmic dawn. The upcoming Nancy Grace Roman Space Telescope promises to expand the sample of these mysterious early galaxies into the thousands, potentially revolutionizing our understanding of how the universe evolved from primordial simplicity to today's cosmic complexity. The universe's early chapters are being rewritten with each Webb observation, revealing a cosmos far more dynamic and capable than we ever imagined. These galaxies that shouldn't exist are teaching us that the early universe was a place of remarkable creativity, assembling cosmic masterpieces in timeframes that challenge our deepest theoretical understanding. The story of cosmic evolution is far from over. It's just beginning to be told properly for the first time. But here's where it gets even stranger. If the early universe could build galaxies this fast, what happened to them? Where did these cosmic giants go? And why does the universe we live in today look so different from what Webb is showing us? The answer involves some of the most violent events in cosmic history, and a force that may have hit the pause button on star formation across the entire universe. If you want to hear more interesting facts about space, check out this video right here, because once you see, the universe will never look the same.